These are the Chapter 5, Part 1 video notes for Section 5.1. So we're going to talk about classifying triangles and sides by angles. So we have different triangles where we classify by sides. So sides, you have a scalene. So you have no congruent sides and no congruent angles. Remember, congruent means the same measure. So nothing's the same. All the sides and the angles will be different. Isosceles has two congruent sides, so two equal sides, and then that means you have two equal angles. What you will notice that if I could go across this angle and this angle, the ones that you can crisscross are the two congruent angles. For equilateral triangles, I have three equal sides and three equal angles. Now we're going to talk about classifying by angles. So when we're looking at this, we're looking at the inside angles. So an acute triangle means all three of the angles are less than 90 degrees. So if I have, let's say, I have one that is 60 degrees, and then we can do one that is, 45 degrees. So we have to figure out how many degrees that last angle is. So we take 180, take away 60, take away 45. That last angle is 75 degrees. And you can see all three of these angles are less than 90 degrees, so it makes it an acute triangle. A right triangle means you have one 90-degree angle or one right angle. So a right angle means it's 90 degrees, only one of them. An obtuse triangle means you have one angle that is obtuse, one angle that's bigger than 90. So I could say this one is 120, so that makes it an obtuse triangle because you have one obtuse angle. Then you have called an equiangular triangle. An equiangular means you have three congruent angles. So all my angles are the same. So all triangles are 180 degrees and you have three equal angles. It means each of these angles is actually 60 degrees. So anytime you see 60, 60, 60 inside a triangle, it will be equiangular, equal angles. So now we got to figure out and classify these triangles by the sides and the angles. So I'm looking at the sides. I have 6.1, 8.7, and 7.4. None of them are the same, so that means it's called scalene. Now take a minute and go look at the angles. If I notice that all these angles are less than 90 degrees, this is called an acute triangle. Let's do the same over here. So I've got different side measures, so side lengths are different. Once again, this is scalene. Now look at the angles that are on the inside. I got 32, a 90 degree, and a 58. So because I have this 90 degree right here, this is called a right triangle. Notice I'm not saying right angle or acute angle. It's triangle, acute triangle, right triangle. All right, so we got to prove the following triangle is scalene. That means all the different sides are equal. So if I'm looking here, I'm going to find the distance between each of my points. So just to remind ourselves what the distance formula is, x2 minus x1 squared plus y2 minus y1 squared. So I'm going to use P and Q right now. So x1, y1, x2, y2. So this is from P to Q. So x2 is 6 minus -1 squared plus y2 is 3 minus 2, and it's squared. So minus a negative turns to plus a positive. So I now have 7 squared plus 3 minus 2 is 1 squared. 49 plus 1 is square root of 50. Now remember, we always want to simplify our radicals. So the square root of 50 is 25 times 2. 2 is prime. 25 is 5 times 5. So I end up with 5 times 5 times 2. Grab your pair, pull it out, you write it down once, and you keep the 2 inside. So square root of 50 is really 5 square root of 2. All right, so the length here is 5 square root of 2. So now it's 1. Now I got to go through and I'm going to find a different one. So next I'm going to use P and I'm going to use O. So x2, y2. So from P to O, So we've got 0 minus negative 1 squared plus 0 minus 2 squared. So plus a positive, we get 1 squared plus negative 2 squared. So 1 plus 4 is the square root of 5. So we have the square root of 5 right there. All right, now I got to go from O to Q. So I'm going to do x1, y1, x2, y2. So inside I have 6 minus 0 squared plus 3 minus 0 squared. I get 6 squared plus 3 squared, 36 plus 9. And then we get 36 plus 9 ends up to be 45. So we have the square root of 45. Break it down, square root of 45 is 9 times 5. 5 is prime. 9 is 3 and 3. 3's are prime. So 3 times 3 times 5. Find your pair, pull it out. I end up with 30 square root of 5. So now look at your angles. Or I'm sorry, look at your side lengths. 5 square root of 2, square root of 5, 3 square root of 5. They are not the same. So we know that this is scalene, so I've just proved it's scalene. Now I have to prove that it's a right triangle. Notice it says scalene and right. So I proved that it was scalene because my 3 sides are not equal. And if it's right, that means this should be a 90-degree angle. And if it's a 90-degree angle, that means it's going to be perpendicular. So now I need to find the slopes of P to O and O to Q and make sure that they are perpendicular. So my slope of PO, I'm just going to go through and find my slope. 1, 2, I rise, 1, I go over. So I end up, I rise 2, I run negative 1. So my slope of PO is negative 2. Now I'm going to find my slope of, and I'm going to do the slope of this line, O to Q. So once again, I'm going to do my rise to my run. 1, 2, 3. Then 1, 2, 3, 4, 5, 6. So 3 over 6 is 1/2. So now you got to ask yourself, is negative 2 and 1/2, are they perpendicular slopes? Are they opposites and reciprocals? Yes, they are. So right there, I have now proved it's scalene because all my sides are not the same. And I've proved it's right because it's a 90-degree angle and my slopes prove that it's a perpendicular lines. So there you go. Next it says, identify angles and sides in isosceles triangles. If 2 sides of a triangle are congruent, then the angles opposite are congruent. So right here are my 2 equal sides, so here are my 2 equal angles. And then the vice versa. If I have 2 equal angles, I have 2 equal sides, and they're always the ones that are across from it. So looking in here, it says complete the statement. So it says HG. So HG is here, and then HK is here. These are my 2 congruent sides, so I'm going to mark them. So which angles are congruent? So dink, 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 that corner, dink, 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 that corner. So this angle and this angle. Angle HGK and angle HKG. Now let's try again. Next part says angle KHJ. So KHJ is this angle. And then it says KJH, which is this angle. Then which sides are congruent? So if those are my 2 equal angles, this is my equal side. Go across, this is my equal side. So line HK is congruent to line KJ. So now looking here, we have to solve for X and solve for Y. So if I'm looking at this angle right here, or that triangle, I see that I have 3 congruent angles, which means this is 60, this is 60, and this is 60. So that means if I have 3 equal sides, or 3 equal angles, I have 3 equal sides. So this side is equal to this side is equal to this side. So that means all of these are 4 in length. So Y is equal to 4. I also see that I have isosceles triangle right here because of this angle and this angle. So that means I dink, 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 cross it. This side is equal to that side. Now I know that this is 4 and this is x plus 1. So I can say x plus 1 is equal to 4 because they're congruent lengths. Subtract 1, I now know x is 3.